So hello future achievers, okay, welcome back to another session, and this session is going to be a little bit boring and theoretical, but let's start this session, okay. And in this session we are going to discuss the ways to determine the equivalent mass of elements. Now there are a lot of reactions we do with some metals or non-metals to find out their equivalent mass, okay, and those reactions we are going to study in this particular lecture, okay. So the first method of finding the equivalent mass is by reacting the metal, okay, with some acid to evolve a hydrogen gas. So when some metal reacts with a hydrogen to evolve a hydrogen gas, okay, in that case we can determine the equivalent mass of the element, okay. Let's see how we do it for this particular method. Okay, so the metal is reacting with acids, okay, metal is reacting with acid, okay, some acid is reacting with it, okay, HCl, okay, and then to evolve a hydrogen gas, okay. So hydrogen gas is evolved and MCl. Now this is the reaction. So the type of questions that you are going to receive. So in this session you only need to focus upon the type of session and how the formula is going to look like. Type of session, formula, type of session, formula, that's it, okay. Now see, the question might look like calculate the equivalent mass of metal if 0.5 gram of the metal evolves 112 milliliter of hydrogen, okay. Now it means if 0.5 gram of the metal is evolving this much amount of hydrogen, okay, this is 112 milliliter. If I want to know what is the mass, then what should I do? First of all, I have to convert this into liters and find the number of moles of hydrogen, which is 0.005, okay. Now 0.005 is the amount of moles of hydrogen, okay, which is directly given. Then in that case the equivalent mass will be mass of metal into 1.008 divided by mass of hydrogen which is evolved, okay. This is the formula, got it, that's it. This type of question, these are the formulas, okay. So what is the mass of metal? 0.5, mass of hydrogen evolved 0.01, and here 1.008 is the equivalent, what do you call it? Remember this number, only this number is going to change for different questions. This number 1.008, this number is right now over here, this number is going to change for different questions. So in case of hydrogen, okay, this number is actually 1.008, so that atom's equivalent mass, got it. Now so this is our answer. You can actually take this mass of hydrogen, instead of mass of hydrogen you can write volume of hydrogen into the density of the hydrogen, got it, that's it, you can do it. Now focus on this number, everything is going to change and this number is going to be constant. See, I mean not constant, but it will be fixed. For an example, here a metal, so there is oxide formation method, okay. Okay, in case of this oxide formation method, oxygen is reacting, okay, what is the mass of oxygen? Tell me what is the mass of oxygen? 16. But what is the charge on oxygen? 2, 8. Now this number is what? 8. Got it? In case of oxide formation method, okay. So to see how we are going to do this, okay, I hope you get the logic for this particular number, okay. At last I will tell you the logic also, okay. Now metal reacts with oxygen to form a metal oxide. So a metal weighing 1 gram forms 1.6 gram of its oxide. So this is not the mass of oxygen, this is the mass of oxide. I want to know the mass of oxygen. So 1 gram was the metal, 1.6 gram was the oxide. It means obviously 0.6 gram would have been the oxygen, okay. So mass of metal, mass of oxygen into 8, that's it. This is the equivalent mass, okay. This is not some formula that you need to remember. I think it will get into your intuition itself, okay. Now same way the mass of oxygen can be written with a different manner, like mass of metal oxide minus mass of metal, this way also, okay. But better you remember these formulas also, okay. I told you the logic behind it, mass of the atom divided by the charge, okay. In case of hydrogen, what was the mass? H2, right, okay. Hydrogen, what is charge on hydrogen? So mass is 1, charge on 1, so that's why you are multiplying with 1 in case of hydrogen. In case of oxygen, what we are multiplying with? Oxygen, sir, the mass is 16 and the charge is 2, so we have to multiply it by 8. Now in this second case, okay, sorry, I mean third case, chloride formation. First of all, let's predict the number, okay. Chloride is what? What is the mass of one chlorine atom? That is 35.5, okay, right. And what is the charge on that atom? It is 1, so it means 35.5 divided by 1 is 35.5. So now the number should be 35.5. Is it 35.5? Yes. then what should be there? Mass of metal, mass of chlorine, that's it. Okay, that's what we have to do. So metal weighing 2 gram, so mass of metal is 2 gram, forms 6 gram of its chloride. So that is 6 gram of chloride, not the 6 gram of chlorine. Okay, that chloride is the compound formed with the metal and the chlorine. So 6 gram of chloride forms with 2 gram of metal, then obviously 4 gram would have been the chlorine. Okay, so this is 2, this is 4, got it? 2 by 4, cancel, cancel, this is our equivalent mass of that atom. I hope I am understandable, right? Now let us go to the next particular method, metal to metal displacement method. Now this is an important thing, always remember, when one metal displaces the another metal in its salt solution, this is the king formula that you need to remember. Okay, just like our sponsor King's Medical Academy. Okay, equivalent mass of the displacing metal, equivalent mass of the displaced metal is equal to mass of displacing metal A, mass of displacing metal A, mass of displaced metal B. Okay, now see, 1 gram metal A displaces 2 gram of metal B. So mass of displacing metal, okay, metal A mass is 1 gram, this mass is 2 gram, right? Equivalent mass of B is 50. Then what is this mass? Equivalent mass of A, just do the calculation, take the 50 on that side. So half into 50, that's it. So the only thing you need to remember in this question, this one was the important one. Okay, this one is the important one. Remember, when two metals are displacing each other, then their equivalent mass ratio should be equal to the mass they are displacing. Okay, I hope it is understandable. Okay, one of the formula is written here. Okay, this is the same formula as this one. Okay, they have just taken this thing on the other side, so it's not a different formula. You can forget the below formulas. It's not a different formula. Okay, don't try to hush yourself. Okay, now we have double decomposition method. It means one element is going to decompose into two other elements. Okay, now see how the question looks like. 5 gram of AB react to form 7 gram of AD. Okay, calculate the equivalent mass of A if equivalent mass of D is this. So now we need to calculate equivalent mass of A and the equivalent mass of D is given. Remember, how can we find mass of A? See, this is AB and this is AD. Okay, 5 gram of AB reacts to form 7 gram of AD. It means the mass of A is 7 minus 5. This is the mass of A. Now how can you find equivalent mass of A? Nothing. Mass of AB upon mass of AD into the equivalent mass of AD. That's it. Okay. And now you can see the ratio. By the way, you can see the ratio. Equivalent mass of A upon AD is equal to equivalent mass of AB upon AD. Okay. It is as similar as the previous formula itself. Okay. So it's nothing different. So the formula we used is also mentioned over here. This is the same formula. Okay, no need to write this. I hope you got this session. I hope this session was not that much boring. Okay, it's very theoretical topic, so you just need to just grasp the concepts. Okay, and there's something special about this session. We'll come in the next session with some special topic. Till then, bye bye. See ya. Have a nice day. Keep studying.